Central, congrats on the first. Okay. I think today's a linear algebra day. Maybe we should look at orthogonality. Is that where I was looking before? I don't really remember. I'm gonna look here though, because why not? No, before I was looking at eigenvalues and Stuf. Remember what the hell, how the hell projections work? The fuck. I've seen this way more. I've seen that before. I just can't remember what that actually means. Also, what a terrible way to start a section. Um, what's x hat here and what's a and b? Okay, x hat is the direction. A is the scaling. But this is isn't this a scalar? How is x hat equal to a scalar? Wait, is x hat the scalar multiple and a is the vector? Why would you do that? What is this notation? Hey, Joseph, orthogonals? Yeah. X hat is the... What? Hey, Naman. Why? Okay, fine. 219. This is the book here. It's not my favorite, to be honest. I wanted kind of some kind of an introductory text to look through though, just to remember the linear algebra stuff that I've already learned. And I would like to move to a more advanced book. I'm not sure if I'm going to actually do it at this point now, but I've been trying to remember the linear algebra that I've forgotten. It'd be cool to get into more advanced linear algebra. But I'm kind of thinking of switching gears and like doing this for maybe like a few more weeks and then getting into complex variables, because I think that's a really important thing for me to learn too. No, I'm just go back to Axler. Yeah, I was gonna do that one or something else that I can't remember. This book is decent though. It's not perfect, but um the author of this book has a bunch of MIT OpenCourseWare lectures on linear algebra, so I've been watching those lectures at the same time as looking through his book. Using x hat to mean a scalar though that just seems terrible to me. I've been trained to think of x hat as a unit vector or like anything hat. I feel like really the only important thing here is that we're using a dot b as our scaling. Oh, duh, yeah, okay. A dot b measures how in line a and b are, and you're just multiplying that inlineness with a unit vector pointing in a's direction. Can the projection be longer than the original vector? Probably. Wait. Um, we want to. Um, let's pretend A is 1, 1. And then let's take B as something that's way longer. What does this look like? I guess 3, 8. Just not too much about the scaling. And I want to do. I can remember how notation works. I assume like it would look like projection of B onto A. I think is how the notation. I can't remember, but let's not care about it. We would do A dot B. So oh no, this is the A dot A is the square of the magnitude, right? I mean I know I've talked about this exact thing before and I figured out. I want to re-figure it out though, because you can think of it as A dot B over the magnitude of A times A over the magnitude of A. And I don't remember how exactly that works. 11, but let's just do this raw calculation first. A dot A, 2. And okay, so the answer is yes, we can have a projection that is longer than the actual matrix. 11 over 2 is 5.5. So we'd be going like out there, wherever that makes a right angle. And how does this formula break down again? So I want to think about A dot B over the magnitude of A times A over the magnitude of A. So this is just the unit vector pointing in the direction of A. That's fine. This thing is it's also the magnitude of b times cosine theta, which makes perfect sense. Okay. Yeah. Okay, good. I feel more comfortable with that now. I'm probably going to forget it again in 2 seconds, but... What? What are you doing to me, Firefox? Why do you do this? Okay. I literally just clicked on my Firefox to bring it back up. Oh. MVA0, thank you for the follow. Maybe Emma, I don't know. Yeah, when I clicked on my Firefox just to bring it back up, it gave me a pop-up asking if Firefox has permission to make changes to your device, and I feel like it does to me at least once a week. And like, how often is Firefox freaking updating? It's really annoying. Make P is m by n, but its rank is 1. A transpose over A transpose A. And A transpose, that does form a matrix. A transpose A would be a scalar. And it's really just a rearrangement of the projection formula we just looked at. And yeah, projection matrices have this cool property that makes sense that p squared should equal p, because doing a projection twice shouldn't change anything from the first one. Why is this one wandered inside of the plus sign? That seems weird. I minus p is a projection. Produces the other side e of the triangle perpendicular part b. Why is that? Oh, I get it, because it's like b minus pb. Okay, yeah. I minus p times b equals b minus p, which is e in the left null space. It's a lot of letters to throw out. Eldritch, you know it. It's been a minute. I hope you've been good. I'm still trying to figure out what this means. I minus p times b equals b minus p. I know what, like, yeah, this is b minus p is what you get after you multiply this out. Why is that e in the left null space? B minus P is just E. Why is it in the left null space? The left null space of what? A B? Wait. No, you don't. You know the null space of a vector. You have the null space of a matrix. Doing math always. Hey, Stefan. Yeah. Hope it's going well for you. Chasu. That's a pretty good response. Yeah, who's nerdier? The person who does a math stream or the person watching someone do a math stream? Kubrick. Please tell us something for me, bro. I just don't get the answer. I don't understand from the net. Hey, Tree, I'm back. Oh god, what is that limit? Yeah, little do you know, Chasu, I have Eldritch taped to a chair right now. E raised to the root tangent x? What? Minus e to the root x all over root tan x minus root x. What is this limit? Yeah, Jasu, I'm desperate here. Anything for an extra viewer. Well, this is screaming Lopitals. Well, we need to plug in 0 to test. Tangent pi over 8. You probably need a double angle for that. Okay, let me quickly answer Triambek's question. Say, or like it's a bit like quicker. I would use this identity here if you want to figure out tangent of pi over 8. Because we can say it's the same. Wait, can we? Yeah, because we can say it's the same thing as tangent. No. You wish there were more people in here, more nerds? I was just kind of thinking about that. There's a lot of cool stuff that isn't that people aren't taking full advantage of. Like, so the math community just isn't like quite big enough. Like, and I'm thinking of like the classes that like the other math streamers actually teach. Like, it's such a crazy, awesome opportunity. No, this is not the right identity. This identity goes the wrong way, doesn't it? If I let theta be pi over 4, then I'm getting pi over 2 inside there. Theta would have to be pi over 16, but who knows what tangent of pi over 16 is? I don't know, maybe I'm thinking about that. I don't know if that works. At least not the way that I'm thinking. Okay, since that wasn't as straightforward as I thought, let me actually do Kubrick's question here. I thought that would be a lot more direct, but it's not. Doing this limit, we need to test plugging in 0 just to see what we get here. So tangent of 0 is 0. So we're getting 1 minus e to the 0 is 1, 0. Tangent of 0 is 0. Minus, wait, what? Am I doing something wrong? This is just a number. Pi to the 1 over pi? Oh, it's just some crazy number. Lucas is probably not anything. Oh, yeah, duh. Square root of 0. But this is infinity. Oh no, it's 0 over 0. Okay, yeah. So we do get an indeterminate form. There we go. So we can use L'Hopital's. We're getting 0 over 0, and that's indeterminate. If it was 1 over 0, that'd be infinity. Okay, so if we L'Hopital's this... Oh, that derivative is... Ugh. Okay. Let's just do it. Root... What am I writing? E to the root tan x. Now chain rule. We have to multiply by the derivative of the exponent. It is going to become slop. Oh, that's an interesting idea for the tangent of pi over 8. I'll look at that more after the limit here. This isn't as clean as I thought it would be. Or, for whatever reason, I was imagining we get something that looks a little bit different. I don't see another way, though. Derivative of tangent is secant squared? Dude, I need another... I need its own line. Minus e to the root x times 1 over 2 root x, and that's it. Divided by 1 over 2 root... Oh, this can potentially still work out? Well, no, it's not going to work out. I thought this would be a good idea because we'd be able to cancel everything but the e's, but that's not really how this works, does it? We don't get a cancellation here. Second one is easier with geometry. Okay. Okay, let's not delete the L'Hopital's work, but let's put it to the side, because that seems like a dead end. You're gonna ask potatoing again? Oh no. Well, wait. Just as a test, if we plugged 0 into this... Kubrick... alright, I mean... We can look at that. Factoring e to the root x out. How does that affect this? It's going to be e to the root tan x minus root x, I think. If I'm doing my exponent rules right. Maybe that's something. Is this an identity? That's an identity? What identity is this? What cursed person is making up identities that look like this? Hey, Mod. I'm good. How about you? E to the y minus 1 over y is 1. Really? As y goes to 0. Of course. Oh, funny. Yeah, e around 0 is approximately linear. Wow. And so Kubrick is, and so you're saying, so this gives us the answer immediately because we can split the limit in half. This piece here goes to 1, and this piece here also goes to 1. So the limit is just 1. What a crazy thing to just know. It makes sense. Uh, okay. Thanks for the question, Kubrick. All right, so Wapitals, get out of here. Let's bring the tangent question back up. JE, yeah, that makes sense. I really dislike JE questions because of stuff like that. So I'm interested to see that the next question was to calculate tangent of pi over 8. And Mert has suggested two seemingly interesting techniques here. Draw a triangle which has pi over 2, pi over 4, pi over 4 angles. So a right angle, pi over 4, pi over 4. Extend one of the edge of the triangle as isosceles triangle as pi over 8. Where does the pi over 8 angle come from? If I extend it like this, isn't this angle now a right angle? It becomes pi over 2, not pi over 8, right? Not from the right side. Okay. Oh, bisect one of these angles. Extend its bottom left corner from the outside. Oh God, I know this must be hard to explain in words. I'm not sure. I can't be interpreting you correctly here though. Oh, wait, you're talking about making a triangle like that? And that one is pi over 8? What does that do for us? This intersects with that? I don't... That can't be true. Can it? Oh, yeah, okay, it can be, yeah. Because we can choose how far to extend out. So we can just go out far enough that a pi over 8 angle happens to coincide with that same point. Okay. And we're interested in tangent of that. So yeah, I mean, we can definitely get that side. Yeah, I want to try that technique too. Yeah, so we could do 1 root 2. Like, do we need to introduce a variable here? Yeah, this one is isosceles. Oh my, wait, you're saying this triangle is isosceles. How do we know that? Wait, so this angle here is pi minus pi over 4, so 3 pi over 4. And that means this angle up here is pi minus pi over 8 minus 6 pi over 8. God, that is pi over 8. What the hell? Wow. So that length there is root 2 as well. So then tangent of pi over 8 is opposite 1 over 1 plus root 2. And you could rationalize that. 1 minus root 2 over 3? No. Uh, that will be 1 minus 2 is negative 1. So root 2 minus 1? What an interesting solution, Mert. Yeah. Thank you for finding that. I also want to look at your other idea that Triumbach I think is going down to, which is letting tangent pi over 8 equal x, and we know that tangent pi over 4 equals 1. And apparently 1 minus x squared equals 2x. Is this from... How do we know that? We neglect the negative x in the first quadrant. I don't know how I get seek equality. Am I missing a trig identity? It looks a bit like the double angle, but it's not quite. '20 streak? Nice, Jed. Since one... It is using this identity? If we let theta equals pi over 8, we get tan pi over 4 equals 2 tan pi over 8 over 1 minus tan squared pi over 8. 1 equals 2x over 1. Oh! Okay. It is from that identity. Okay. Then just to really bring it home and show that we get the same value, we're gonna have to quadratic formula that. Oops. Okay. Minus 2 plus or minus square root 4 minus plus 4 over 2, right? Minus 2 root 2 over 2. 1 plus or minus root 2. And yeah, okay, and this is negative. We neglect the negative solution because we know it should be positive. Okay. Nice. 2 different ways of doing tangent pi over 8. Okay. If there's a question, let me know. If not, I'm gonna go back to looking at linear algebra stuff. I was gonna choose a section out of projections here, but I was just kind of looking through the actual like section first. A-levels exams on 2nd of May. Oh, dang. Good luck. A-levels do not seem easy. I've had people give me questions from there, but before. Math P1. Math exams. Oh, is that a Friday? Oh, it is. Even worse. Yeah, J advanced questions are they are from another universe. Five seems like it could be cool. That is full of non-Euclidean space. Oh my god. I've been reading about non-Euclidean spaces in the universe, and it's crazy. It's mind-blowing. A-levels are multiple papers though. That is nicer than the format you set. Do you have to do like one mega test, Jasu? You paid circular measure. It took you half an hour to figure out. One question of 6 marks. You did a recent past paper. Oh no. Yeah, there's always those things that just like trip you up. Like, you know, whenever I was taking class, I always had like a weakness somewhere. It felt like. Okay, so the projection matrix for A1 is it's a column times a row. I need to make sure that does give a matrix. -1, 2, 2. -1, 2, 2. That's 3 by 1. That's 1 by 3. Good. Good. I do need the scale factor too. 1 over that dot itself. 1, 4, 4, 9. You indeed had one exam for math, so split into a non-calculating calculator part during the same day, whereas the same over everything covered in the past 2 years. Jeez, Jasu. You took the math GRE, I guess that's kind of like being tested and everything. Yeah, I did the math GRE too. I mean, at least that's for getting into grad school at least, so it has a better excuse. But yeah, the GRE really does test on everything. Yeah, yeah, we're talking about A levels, Joseph. Um, yeah, but Joseph for 2 years, that's kind of like we have a with how America does AP classes, which are classes you can take in high school. that are university level. Like there is a test that's sort of 2 years of high school. It's basically like a full year's worth of university calculus. But even then, it's not. I think the ALs probably the ALs that you took are probably a bit more intense. Like that's kind of like the closest that we can do. Oh no, you didn't do ALs. You did a different thing. I think that like the ALs had changed or something. Um, Weird curriculum more similar to IB. Okay. Hey, Mosam the engineer. Okay, so 1/9. So the first column of this 3x3 matrix is -1 times that column. So we're just taking multiplying by a row on the right is like choosing multiples of the column on the left. So we're choosing a -1 multiple of that column. Then we're choosing the double of that column. And again. You sit with the British Council. There are arrangements that can be made wherein you sit all the papers in one sitting. That sounds very fancy to sit with the British Council. I don't know why you'd want to sit all papers in one sitting though. That sounds crazy. Do Abel's math and further math in 2 days? Yeah, there you go. Just knock it all out. Are A1 and A2 perpendicular? Are we gonna get the zero matrix? Is that what's happening? A1 dot A2. -2 plus 4 -2. Oh yeah, they dot to 0. Okay. So I'm expecting the zero matrix here. Um, 1/9. Okay, 4, 4, -2, 4, 4, -2, -2, -2, 1. This is kind of an interesting rearrange. Like, this isn't really a transpose. Well, oh no, it's like a transpose on the other diagonal, right? Normally we do transposes across the main, the main diagonal, but it's like we did transpose across the, is it called like the anti-diagonal or something? I bet that someone has named that. Okay, let's do, I was curious, they named it P1 and P2. I'm doing this weird thing. Oh wait, so is an independent candidate, is that someone who's like not a UK citizen or something? Questions on integration? Do you have a specific one, Fatima? Like, is there a certain type of integral that you'd want to see? That column, that row. 4, minus 8, 4, 0. That column, that row. 4, minus 8, 4, 0. That column, that row. Minus 2, 4, minus 2, 0. Yep, all going according to plan. That, and that. Minus 8. No? Oh, yeah, minus 8, 16, minus 8. There we go. Minus 8, 16, minus 8. Yep. 4, minus 8, 4. Minus 8, 16, minus 8. Minus 8, 16, minus 8. 4, minus 8, 4. Yep, okay, all zeros. Volume of rotation? Yeah, we can do those. So, unless you want to give me a specific one to work on, I'm just going to choose one off this site. This is Paul's Online Notes. It's a website that I really like for learning calculus for the first time, at least. Here we go. The first page goes over rings and washers, and sometimes it has different names depending on who's teaching it. And the next section goes over cylindrical shells. And so I'm just gonna choose. I guess we can. I could even do one of each if you want, but I'll just choose one off the rings and washers page to start with. There's also the practice problems too, where you can get even more like problems with their solutions. It's 155 per paper for ICs. The piece testing center you're gonna sit in, and wow, yeah, that is expensive. Okay, well, this one looks like a finicky one. Let's do that one. Hey, Yash. You can type it there in chat, or you can put it in my Discord. Okay, so I think it's really helpful to have a graph of the functions that we're working with here. So let's do that first. So x squared minus 2x, that's a parabola. The roots are at 0 and positive 2. And it's facing up. Then y equals x is just a regular line that looks like that. Maybe I should have extended this parabola up a little bit. Okay, and we want to rotate the this region between them. Oh my god, what kind of shading is that? About the line y equals 4. So let's figure out, before I draw on the line y equals 4, let's figure out where their intersection point is up there, so we know what we're working with here. So I'm going to set the two functions equal to each other to find where they intersect. So x squared minus 2x equals x. So subtract the x over x squared minus 3x equals 0. Factor the x out. Okay, so the intersection points are x equals 0 and x equals 3. And we can figure out what the y value is. It's much easier from the line, y equals x. So we know this intersection point is going to be 3, 3. Yeah, I should be able to figure that one out, Yash. You'll be up after this question. Okay, so then now we know the line y equals 4 is going to be up above that intersection point. Up here. Okay, so now we're ready to start setting up an integral here. We're going to use rings here. Or sorry, washers. And the formula for washers, as I think of it, is pi times the integral from a to b, where a and b are your intersection points, of the outer function squared minus the inner function squared. Well, we should say radius. How should I do this? It's not just the function, it's the radius. Dx. And so how we get the radius, well, yeah. For the outer, we always start with the one that's farther away from our axis of rotation. So the axis of rotation is y equals 4. The one that's farther away is the parabola. And so if we want to get the radius, just take the parabola and subtract off the actual axis. That's kind of like the thing that you can always do. So pi, our intersection points set are 0 and 3 in terms of x. The outer radius then, take the parabola, x squared minus 2x. Now subtract off 4, parentheses squared, and then the inner radius is going to be the line, and it'll be the same thing. Just take the function, subtract off the axis. Dx. Our integral setup now, all we have to do is follow through. Hey, NA. 3.14. Thank you, Jed. This is annoying to square, isn't it? There's no trick we can pull to make it easier, I don't think. Really, Paul? You're gonna make me do this? Yeah, we just have to do it, unfortunately. Okay, x to the 4th minus 2x cubed minus 4x squared. Throwing shade at Paul? Yeah, just Wolfram it. That's the real answer, yeah. You know what? I do like the suggestion of Wolframing it. I'm gonna trust that you know how to square that for yourself, and I'd like to not spend or your question I think is more about the actual integration, and we've already done the hard part here, so let's not spend more time than we have to on just algebra. Oh, you can do that with the grid, right? I don't think I learned that way, but I think it sounds familiar. X to the 4th minus 4x cubed minus 4x squared plus 16x plus 16. minus that thing squared. That's easy enough to do in your head. Minus 8x plus 16 dx. 0 to 3, x to the fourth, minus 4x cubed, minus 5x squared, plus 24x. Oh, and 16s cancel, that's nice. Okay. Now we can integrate. There was a shortcut? Dang it. Too late now. Three to the fourth is 81. Oh my god, Paul. This is too many fractions. Uh, 12 times 9, 120 minus 12. 108? Oh, it is x to the fifth. Thank you, Fembox. Just to make it even more annoying. Is that 273? Yeah. 243? That sounds better. And 12 times 9. I need to verify that in my head. 12 times 9. Yeah, that's fine. 108. I know I don't need to do it in this like level of detail. Just like, well, like mentally I feel like I need to see it through like this. Oh, I don't want to do this fraction math though. Um 16? 18? No, 18. Actually, nah, that could be worse. 18 times 5, that's 80? Yeah, no. 90. 243 minus 90. 153 over 5. I corrected it. Don does physics. Oh my god. That has to be Dr. Cook. You can't hide. Now let's check the answer. We got our graph right. Oh, that's backwards from how I did. It shouldn't matter though because it's squared. Yeah, 153 pi over 5. Noish. Don does chemistry. Don's no good at chemistry. So yeah, if you want to say another one with shells, Fatima, we could definitely do that. Or another one that's Don does all. We need a Don does your mom. um But yeah, so I'm happy to do more, but there's someone else who posted a question that I want to take a look at, and then let me know if you want to see more solves of revolution. Yeah, if you do it enough, you can kind of like see the patterns there. It is just a very weird thing. Oh, thank you, Jed. I don't have that set up anymore. I removed that. Um, yeah, I I keep saying that I want to program a queue system that'll track the stuff for it, and I can like rearrange it. And I want to keep like timestamps of when tasks get switched. I don't know if I'm gonna actually follow through on it, but I want to make it. When you're completing the square. Oh, I mean, I think it's more trouble than it's worth, Udon, but yeah, I guess so. If n is an integer and n squared is odd, then n must be odd. I assume we would take n squared equal to 2k plus 1. Where k is some integer. Why not n? Well, we're trying to prove that n is odd. We can't just say it's odd. I mean, it is possible. Oh, well. There's like the contrapositive or something. Or like I forget what exactly it is, but like there is if you have an if then statement, there is the way you can flip it around and negate it. I think you do like if p then q, like not q, if not q then not p, I think is how you would flip it or something. And so that would let you start with n. I guess that'd be even in that case. I don't know if I have that logic correct though. Oh, nice, Mert. Okay, so Mert is saying to subtract the 1 to the other side. So n squared minus 1 is 2k. And now this is the difference of two squares. What does this mean? Since 2 is prime, it must divide one of them. In both cases, n is odd. Ooh. So if 2 divides n plus 1, then n is odd. Oh my god. Please don't spam. Go in timeout. Okay, I no longer think that's Dr. Cook. Dr. Cook is at least like funnier with his trolls. um, and then the other case, if 2 divides n minus 1, then n is also odd. I think it's just the entire proof right there. So thank you, Mert. Physics can definitely get really crazy. Who was the person who asked that question? Does this make sense? It was Yash. Oh, it was a Ney who changed their name to Donda's Physics. Interesting. Okay. Well, I hope that makes sense, Yesh. I'm kind of curious about the contrapositive way. I just want to see like how that looks. If n is even, then n squared is even. Oh, that's way easier to prove, isn't it? You can let n equals 2k where k is an integer. Then you just square each side. So n squared is clearly still even there. Yeah, I mean, you would want to keep the n being an integer thing. Okay, nice. Okay. In that case, I'm going to go back to doing studying unless someone asks another question. That question right there is just from Yash there in chat. Oh, good. You're right back to spamming as soon as your timeout expires. Okay, well then you're not going to come back ever then. Goodbye. That was a quick 5 minutes. Time really flies when you're not getting trolled. Okay. I was only. Oh, did I only time out for 3 minutes? I don't know. Either way, that person had their warning. Start talking after 3. Oh, really? Oh, you know what? They made a new account. That's it. New account with the same name because the profile picture is different. They're just doing the game over emote. It's not even a funny troll. Like or like YouTube has some default emotes. And one of them just says like game over, and they just decided to spam that. Okay. Anyway, let's look for a linear algebra question. We just did 5. I'm gonna go make. Oh yeah, people have taken it really far. Like they just dedicate, or there's one day where people just dedicated like a few hours to making new accounts to spam. um, YouTube people are just built different. To be honest, the main reason why I even started streaming on YouTube is just to have an archive for the streams. Um, I'd hate to do it, but there's always the nuclear option of just turning off the YouTube chat entirely. So I think that's an option. I hate to let the few ruin it for the many, but I do technically have that if it turns out to be like 95% trolls. Um, and it would take a lot for me to actually do that, so I wouldn't worry about it. Um, Twitch stores them just for Twitch will store VODs for like 1 or 2 weeks only, and then it deletes them. Unfortunately, I used to manually upload. Like I used to record my streams and upload them to YouTube afterward, but that just became such a huge pain that I just started dual streaming it instead. But um, what am I saying? Yeah, I know. Twitch is like I consider my primary platform. YouTube is just kind of a bonus. Um, you have to right click, find the right option, fill out a few forms, provide your bank account information, consult YouTube ambassadors. Yeah. YouTube's chat tools leave a lot to be desired. It's nowhere near where Twitch chat is. Ooh, we got P yellow. Oh, it's kind of hard to tell. It's a little bit too bright out. Bright sunshiny day inside and out. Yeah. It's definitely warming up. It's nice to have my windows open again. It's annoying. It's always too hot or too cold though. It can never like just be right. Gotta get that tan going. Speedo season's coming soon. I don't tan. I just burn. It's bad. Oh, you like Gojira Udon? Yeah, they're awesome. Oh wait, I might want to do 8 and 9. Chasu. Jesus. You're just going straight for the throat, Jasu. Oh, are you done spamming now, Don does physics? The hardest math that I've done, the math class I took that I found the hardest, I think, was my discrete math class. The professor of it was pretty mediocre though. Got on the banana boat. Yeah, what if this entire stream is just like it's brought to you by Big Pharma? I'm just like secretly trying to sell stuff. Hey, Aziz, sounds tough. Yeah, I mean, some people like love discrete math, and there are some cool things in discrete math, but it's never been something I've been particularly good at. Sunscreen companies, yeah. Um, Yeah, it's easy. It depends on the problem, but feel free to hit me with one and I'll tell you if I can do it. You can put it there in chat or put it in my Discord. You know, I've seen that Dr. Gold is just showing like multiple chats on his stream, and I'm kind of tempted to just start showing both the chats up there. It make it a lot better. I have to figure out a way to actually do that, but you only know the definition of discrete math you like because it has computer science applications. Yeah, even though like discrete math, um, as far as I've seen, like different schools have different ideas of what should get taught in a discrete math class, so they can vary a lot. But it definitely has some cool applications. It's really tricky and it's not a I don't know. I tend to like things being continuous. I guess I like calculus. Algebraic applications more close to symmetry with group theory. Yeah, applications of algebra have always. I know it gets applied. I've never learned where, so it's always been very mysterious. Or I've ever learned where at like a very high level. Like I remember learning a few months ago that like in chemistry, group theory can actually be pretty helpful. And I think that it can also be helpful for like in some parts of physics and like quantum stuff. You love calculus till now? Oh, like what kind of calculus are you learning? Aziz is asking about proving a trig identity. I have a feeling we're gonna need the sum and difference identities. That's not it. Do Don and Little Mermaid have in common? They both like their algebra. Oh my god, I didn't figure out the joke until I got to the word algebra. It's like, where is this going? All right, that's a pretty good one, Jed. What's trying to think is best thing for you in math? You always select cryptography for applied area. Oh yeah, cryptography is cool. To be honest, those are two of my least favorite areas of math. It might be because I don't know enough about them, but um, yeah. Making videos for a year, can you describe your journey? How recently wanted to make videos? You have to have very few views on them. Yeah, so I've been going for 2 years and a few months. Hope you're doing well, Viv. Hope your son is good. Um, I don't know, I just kind of love doing it. The people show up to streams or what keep me coming back. It's just really fun to interact with the with just like people. All right, so let's start from the left side of this identity and try to get to the right side. Skeleton. Oh no. Normal functions, limits, continuity, differentiability, indefinite integration, differential equations, 1 degree. Okay, so yeah, it seems like you're learning. That's like first year calculus type stuff. That's where I really started to actually like math, but yeah, it's probably not for everyone. Yeah, Jed, you are the one person like, oh my god, I hope he doesn't show up to stream to today. That's why I made you a mod too, you know, keep your enemies close. No. You're awesome, Jed, and I'm always happy to have you around. If it's easiest to set that command, I can. But that's nearly the beginning. I started streaming midway through March. Sorry, midway through January of that year. Mental arithmetic tricks, homies know how to do it. I'm sure there's gonna be a trick with making it like 327. You can make it maybe a square or something. Like 323 plus 4 times 323. No, even then that's not that helpful. I don't know. I don't think you've submitted a single quick math that follows the rules. 325 squared minus 2 squared. Oh, you make it a difference of 2 squares. That you still have to do 325 squared for that, though. Does it get bad? I mean, it only gets more complicated, I guess, when you get into like multivariable stuff or higher order differential equations. But I think that's where it gets really beautiful. Because that's where you can get some actually really interesting applications of calculus. So I love seeing places where multivariable calculus in particular get used, because it's just such a, it has just amazing applications, I guess. Like you can learn about how the universe like actually works. Check Discord. Wait. I'm trying to figure it out. Stop your algebra jokes, we don't get them. Me. I don't care about your opinion! Okay. It's a good one. You posted 2, though. Chicks love guys with pants. Their sine over cosine. Oh my god. The idea of a chicken going to a tattoo parlor also is really funny. Very nice memes, Viv. Okay. Sorry about that. Just type in something. 7 plus 3 is 10, and 32 squared is 1024. Just do 1024 plus 32 goes 1056, and sometimes 3 is 21. Wait. 327 times 323. Skeleton is breaking it up into 320 plus 7. Is that even it? I don't think I'm interpreting that right. Wait, yes, this is right. I guess, yeah, 320 squared isn't that hard to get. Because you can do 32 times 10. Um, like that. Oh, okay, yeah. I guess that's the way to do it. Yeah, and that's not too bad to calculate at all. I, I'm gonna refund your points because I didn't really do it, but that is the way to do it. Yeah. Okay, I'm sorry. Let me get back to Aziz's question. So my idea for the problem is to start on the left side of this identity and try to get to the right side. Because on the left side, we can apply the sum identity and the difference identity. And so this term comes from the sum, that term comes from the difference. And now I'm multiplying these parentheses out. Um, and I think we're nearly there. Because that term cancels with that term. So I get sine squared alpha cosine squared beta minus cosine squared alpha sine squared beta. And we should have a Pythagorean identity to bring us home. Where is it? Wait, how do we deal with this now? The sine squared should go away for some reason. We should just have cosine squared minus cosine squared. How do we get rid of the sines? You want to convert sine 2a into cosine squared? Or sine squared into cosine squared? Oh, okay. I was thinking. Okay, yeah. I think, yeah, that's a good idea, Yudon. Um, I said Pythagorean identities, but I was thinking of them in a different sense. But yeah, this is probably what we want. Sine squared is 1 minus cosine squared. So we get cosine squared beta minus cosine squared alpha, cosine squared beta minus cosine squared alpha plus cosine squared alpha, cosine squared beta, and then the two things we want to cancel do indeed cancel. So we get cosine squared beta minus cosine squared alpha as desired. Nice. So yeah, I hope that makes sense, Aziz. Let me know if anything I didn't make sense. The line element for flat spacetime is messing with your head. But wait, well, for flat spacetime, it's really easy, right? It's just regular Euclidean. Do you mean like the line element with like minus c dt squared plus the regular flat spacetime? Hey, color cone, we're doing well. Yeah, I've been so I have a problem, and I've already read through all of chapter 4 because once I start reading about special relativity, I just can't stop. Apparently, I just think it's too cool. Um, so I read the entire thing in 2 days, and I'm gonna have questions, but yeah, trying to visualize much of anything in curved space time, like it gives me a headache. You only have a few pages. Okay, good. I'm glad that we'll both be on track for Saturday then. Hey, famished. Don does coffee. I mean, I feel like drinks coffee would be better. If I'm doing coffee, I feel like I'm having sex with it. Well, you guys don't know what I do in my spare time. Um, what was I gonna say about relativity though? I don't know. It's just crazy. I I I think it's amazing. Doing it as the book is saying is really, it seems like the right way, but it's still really hard to wrap my head around. Yeah, no, color code. Like the last year, I did a reading group on electricity and magnetism, and I started that not even being interested in physics. I just wanted to look for cool applications of multivariable calculus. And I asked a physics streamer, physics and depression, for recommendations on like what area to study, and that's what he suggested. And when I got to the part where they explained magnetism as a consequence of special relativity, like I literally just like I went like what? Like it's so like mind blowing that that's how reality works with relativity. I don't know. I think it's just like the coolest thing. Udon says for the guys in Twitch chat, x5 square is just 2 times x5 squared divided by 4, so you get something ending with 0. Just couldn't focus that long even with simple stuff. Um, yeah, no, I usually like take more breaks, but if I'm really into something, I kind of like the rest of the world melts away. Um, the most depressing arithmetic fact I found out when I played with numbers after school is that 11 to the 0 is 1, 11 to the 1 is 11, 11 squared is 121, 11 cubed is 1331, 11 to the 4th is 14,641, but 11 to the 5th is 161,051. That is depressing. Why does 11 break the symmetry there? Symmetry with one subject in polynomials. All the polynomial classes you've taken have been easy. Apparently, you need to work on your typing too. No, I make typos like that too. That's good though, Hamish. It's good to be good with them. Pascal's triangle. Can you do powers 11 in Pascal's triangle? Oh my god! Wait. Oh, what the? These are powers of 11? They are. What the hell? Until you reach 5. I never noticed that with powers 11 for the first few. You're saying 2 is a base 10. Hey, Jamie Callis. Good evening to you too. You didn't get a chance to find out. You just read saw in a book. Interesting, you done. You have to carry. Oh, like the 10 carries into the 5 is what you mean. So it's like 61051, and that's what you said it was. Oh, that's unfortunate. This is why we should make Pascal's triangle in hex. That way we have a few more powers to play with before that happens. Do the next row. I legitimately never knew this about powers of 11 though. That's kind of crazy. Better physics than maths. Oh, nice. You done. Using binomials. Oh yeah, these are like the binomial coefficients for integer powers. Read from the right. It is probably better to work it out from right to left, right? Yeah. 5, carry the 1, carry the 2, carry the 1, like that? Is that the next power? 1771561. Hell yeah. That's kind of awesome. Something about the act of squaring 11, or like taking powers of 11, builds Pascal's triangle. Why is that? Do you break 11 up into like 10 plus 1? Something like that? Interesting. Hey Slim, hey Obi. Wahaha. That's so crazy. Is that common knowledge, the connection with 11 in Pascal's triangle? It's a reason for your name too? Oh. I remember hearing you explain your name before, but I don't have much background like what like a simplex is. I know, I guess pachinko is just the thing with like the balls that you drop down, right? But I don't remember like completely like following it. Did the disappointment settle in already? Yeah, Skeleton. I think you'd like Academy a piece of site idea stream. If you haven't had the chance to watch much yet, great sense of humor, and he does some interesting math. Not common. He also uses a type of Pascal's triangle, triangle to find equivalence relations. I haven't heard of that. Hey, ND Vine's channel, dang, should be asleep. Do not check Discord. Meanwhile, you posted a problem that you want to see? I'm confused. Famous, do you want to work that problem out or not? Playing the same pachinko style game with n-dimensional simplices, which is a triangle in any dimension. Oh. That's hard to imagine, but okay. that I'm closer to understanding than it was before. Summon me to a problem. All right. We can do this problem. Small structure that can exist. Ooh. Maybe I'll have to ask you next time I can catch a stream so you can explain it like verbally. Lucas, this is Pascal's triangle. it has a bunch of connections with things in math. We were just talking about it because this has connections with powers of 11. Because 11 to the 0 is 1, 11 to the 1 is 11, 11 squared is 121, 11 cubed is 1331. And yeah, by binomial theorem too. Sorry, I should have explained first. Before you even think about this, you build Pascal's triangle just starting with like the top bit there. And what you do is you always have ones on the borders, and then you add whatever is right above it. So that's a 2 there, then ones on the borders. Now 1 plus 2 is 3, 2 plus 1 is 3, put ones on the borders. 1 plus 3 is 4, 3 plus 3 is 9. Sorry, 6. 3 plus 1 is 4. And that's how you build Pascal's triangle. And it has all sorts of connections with other things in math. It's a really neat thing. And so we're just looking at connections with powers of 11. This is not calculus. Okay, so Bell's triangle? Okay, let's do that. We'll do famous problem, and then we'll do Papadoria's problem. So get excited. So we're gonna have a classic Papadoria. Could be fun to program Pascal's triangle. Oh yeah, I bet there's a bunch of Pascal's triangle coding problems. So this is Bell triangle. Partitions of a set in which a given element is the largest singleton. This pattern was much harder to spot. Well, the inside is still the same as Pascal's, right? No, not quite. The leftmost value is copied the rightmost value from the previous row. Maybe there's a neutral row filled by a row very similar to that for Pascal's triangle. Sum of the two values to the left and upper left. Oh, it's 5 plus 2 is 7. 7 plus 3 is 10. Okay. Interesting. And these count set partitions. Huh. I was getting mixed up with 3 times 3. Okay, anyway, let's do a famous question. The only topology you're interested in is how angles in a triangle work, how an angle of 0 would work. You're barking up the wrong tree for that, but someone in chat would at least know where to point you. Okay, so factor this by grouping. So when you look for grouping, you try to look for you pair things in twos, and you factor out whatever is common. So let's try pairing things as we're given them here. You can always rearrange things, but let's just try it with the way that we've been given. 6ab minus 21a plus 4b minus 14. From these first two, the most we can factor out an a, and we can factor out a 3. So let's try factoring that and see what happens. 3a. We end up with 2b minus 7, right? And now from that pair, the most we can factor out is a 2, it looks like. So we get 2b minus 7. Oh, hey, and look at that. And so here's the trick of grouping, which is each of these has a 2b minus 7, 2b or not to be. And so we can just factor it out because it's a common factor. So let's do that. 2b minus 7. And now what goes in here is whatever is left over. So we have a 3a and a plus 2. And that's how you factor that by grouping. It's a really good trick to know. N boxes and K balls, distribute the balls, take pictures, repeat. So many pictures can be taken, count pictures you have. That's the way I do it. Oh, for binomial coefficients. Grouping mentioned, yeah. The GCF is one. Sharing the other way this way seems easier. Yeah, I'm not aware of another way to group. 26 minus 7 is also 19. Yeah. Oh, that's why you're saying that, Lucas? Yeah, my handwriting might not be the best. This is supposed to be 2B. Yeah, Famous if you're curious about the other way that the book is saying to do it, feel free to like post a screenshot of it or something, but otherwise, I think it's gonna be Papadoria time. Mixing up problems? Okay, no worries. All right, Papadoria, you got a calculus question? I think I don't know if I'm ready for it, but it's your turn at least to ask a question. Yeah, because you're not being given a gentle introduction to calculus. I wouldn't blame you. Wait, cosp? What is cosp? And divines, if preparing for JE, you're starting to hate math and physics. I would have the same reaction. JE seems insane. Parabolic cosine? I need to look up what that is. This is the problem, everyone. I've never heard of parabolic cosine. Uh, oh, that's not it. A tool for parents, caregivers, and professionals. I don't think that's it. Oh, what is this font? Hyperbola cosine instead of a unit hyperbola is a unit parabola. I still don't know like how to build that function though. So um I know that hyperbolic cosine is like, e to the x minus or plus e to the minus x over 2 or something. I don't know how that's constructed though. What in tarnation? Oh. Don't tell me that's the definition of parabolic cosine. Skeleton is saying cosp x is equal to cos 2x? Really? That seems a little miraculous. That'd be great, but that's I don't I would need to see some proof of that. Some unusual traffic coming from my network? I'm a human. Found on the first link. Am I human or am I dancer? My sign is vital. Something, something. Um. Wait, this is the same paper, isn't it? Dude, I have to look at a freaking academic paper to. No, this is the same thing. Scroll down on this one. Oh, that's too. Really? You can convert it into a summation, Udon says. And it'll make sense to make cosp the even one. Oh no! It's cosp, which it's new for me too. If it's cosh of 2u, this becomes way easier, I think. But that just seems there's no way this is a parabola though, right? Oh, yeah, math. I don't think if you plug 2x into that, you can't get a parabola out of it. I think we have to go looking for answers in this paper where they use Comic Sans for their title, whatever font that is. Cosh is hyperbolic cosine. It's like cosine, but it's also not. It's completely different from regular cosine. It just has similar properties and somewhat of a similar construction. Um, all right. I feel like you're just coming here looking for a fight, dude. Just talk about math, dude. Don't talk about people's like. You don't need to talk to people like that, dude. All right, see you, Lucas. Thanks for hanging out. How did your professor find these stupid functions? If I go through the trouble of putting this into Desmos, well, how's it gonna look? I don't know if I want to do that. What is IP? Parabolic derivation of trig function. She said, okay, so if you want to do the bonus, do this on the unit parabola. Note the unit parabola is not x squared. It's actually 1 minus x squared. So... Does that problem involve greatest common factors? It seems like it would depend on the values of a and b. I don't know how you would find the greatest... like, I don't think you can find the greatest common factor for those. Remind on or something. Just drive the properties. Yeah, of course. Because it's like, I sort of remember how you find hyperbolic trig derivation. You look at the unit hyperbola and you take certain ratios of like the arc length of the hyperbola to something else. Yeah, this is how you do it. Cosh is the horizontal length. I guess it's gonna be yeah, 1 minus x squared is really weird because if you do it from the origin, I guess you have to do it from the origin. I don't know how you'd find the GCF of this finish. I'm sorry, that seems weird. Um, so I guess you could define an angle like from the y-axis. Like this is positive theta and negative theta is over here. And theta could be from minus infinity to plus infinity. Uh, I don't know if I'll be able to do all your questions and defines if you only can put like one out there though. Theta should be even on -1, 1? Should it be? Yeah, cosp should be even. Simp should be odd. Simp. Oh my god. Um, how do like we need some convenient way to figure out the arc length of the parabola though, do we not? Um, how do they do it for the hyperbola? Simp is the best, yeah. What? The area under cosh is equal to its arc length? That's so weird. What a crazy property. It's not helpful here, but that's crazy. You thought of Michael G. Scott. When did he say x-axis? I'm just looking for like where do they find? Do they just use calculus to find the arc length? Okay, it. Um, the arc length s from 0 to some point x. Yeah, 1 minus 2x squared dx. Wait, are we doing area or arc length? How's it for? How's it just for like regular cosine? I don't know how the regular trig functions are derived. For this is bad. And like for the hyperbolic ones, the arc length. Well, wait. Yeah, I'm trying to figure out if we want this arc length divided by that horizontal distance, or if we want this area divided by that horizontal distance. That's really my question right now. And that's, I don't know. Also, I have to see what this YouTube is. Ah, rest in peace. The area of its hyperbolic sector. So do we want the area? How did Einstein pull up? Oh, is Einstein in here? No, I don't see Einstein. We're supposed to control F. I hovered over special relativity. Oh, I did just learn how the hyperbolic trig functions come up in special relativity. The applications are sick. The applications are scary. That's what you learned? Oh, nice. I doubt Desmos is gonna know cosp. We can try cosp itself. I really don't want to. No, it doesn't know cosp. We could go to what this paper says the definition is. Yeah, Fembox, like the idea of it being like a rotation, but with hyperbolic functions. I don't know what that actually means. And how it somehow ends up just being a constant velocity boost. Like I'd rather not type this entire thing into Desmos. Maybe it wouldn't be that bad. That's what I want to find out. Like, how do they get that? It's just this paper is so freaking complicated. Yeah, this is a real gap in the theory. We really need this. Figure 3. I want figure 3. Show me a picture. Okay, this is something. What is this? Origin? Angle phi? The cursive figure 2, yeah. So they are using the same unit, parabola. Dude, I want to figure out how you derive this. These figures could use some more explanation though. Oh hey, okay, proving the captions come here. Wait, figure 5 is cosp and simp? Well, I wish this would zoom out a bit. Apparently that's what they look like though. Come up with these to make life harder. Yeah, defines. Sector SOPT. S O P. Wait, SOP. That's 4 letters. How does that make a triangle? Oh, S sub OPT. Triangle in quotes, OPT. Why is that in quotes? OPT. Hey, Code to be unique. Yeah, I remember you. Making life miserable with these bonus questions. Yeah. See, I do think that parabolas have some really vague but nice properties when it comes to finding certain things like the area contained in them or something. The argument of the hyperbolic functions is just the area of the sector indicated in figure 2. And Divines, if you have to do this in college, then I think God hates you. No one should have to do this. So is the thing we're taking the ratio of... What is it? They drew the triangle. Elliptic trig will be sine and cos. I guess it would be. Is the unit ellipse just a circle, though? That might be a problem. Acos, as in like inverse cosine gesture. That's a common one. Maybe Papadoria. All right, see you, ND Vines. Yeah, same Papadoria. Okay, this is the form of a unique conic section, I guess, or a unit conic section for some P and Q. The C is whatever the cosine analog is. The S is whatever the sine analog is, I think. Don't ask me what that next line is. So this is the generalized... Dude, this is freaking crazy for any geometry of trig functions. And so you can let one of these be 1 and the other one be 2. What is that Greek letter? This one here is Kasai, or some people say Kasi. It's the worst Greek letter. It's literally like XI. And please speak English in the YouTube chat. I need to be able to moderate it. So this is a generalization of trig functions for different conic sections and maybe more. As I'm interpreting it, at least, if you let these exponents be 2s, this is like cosine squared plus sine squared equals 1. And that's how you can get your normal trig functions. And they make this generalization apparently to get the parabolic trig functions in section 2. I'm genuinely interested to figure out how, like, a not really annoying derivation for these are. See, that's what they let C and S be. They define cosp of 0 to be 1 and simp of 0 to be 0. I assume they define that. Yeah, like it. I'd like to see a more intuitive construction of these than going at it from the most generalized version. Who wrote the paper? G. Dattoli, M. Migliorati, with an asterisk. What? Oh. The Italians did it. M. Quattromini Impe Ricci. It's always the Italians, yeah. Do I love music? Yeah. I think myself as someone who loves music. Hey, Math Magic. So the question is from Papadoria there in chat. It's to integrate cosp of x squared from -1 to 1. And cosp is apparently parabolic cosine. And we're trying to figure out what the hell parabolic cosine even is. And so I'll put the link in chat, but this paper apparently derives it, but it's in a very confusing way. But apparently this is the definition of cosp. My favorite artist, they're a Ukrainian metal band named Ginger with J's. Level 9 GCSE questions. If you want to put something specific in chat, developer, then go ahead, but it's hard to just like find that for myself. I'm okay at this, but not very good sleep hacks. You can try asking a question if you want. Ginger, yeah, the mad woman who sings. That's her. Um, Jasu, the ultimate question is, what is the integral from -1 to 1 of cosp of x squared? And cosp is parabolic cosine. And we're trying to figure out what that even means. Yes, this is from Arxiv or Archive or however you say it. I saw it actually published in a different link, though, somewhere that I clicked off of. You might have nightmares. They're like the one of the only metal bands I've seen with a female lead singer where she does the screaming herself, and I like she sounds amazing. I have pop powder. If you're gonna listen, the song lyrics that got me hooked is Pisces. Yeah, I mean, so if someone else asks a question, I'll switch away Papadoria, but this kind of genuinely has my interest. Like, it'd be cool to figure this out. So silly facts, like, feel free to put your question there. Yeah, I'll spell it out, the actual song that got me interested in them. Yeah. Oh, what is this? What the hell? So there is some type of relationship with cosp and hyperbolic trig. Cosp, you hate to see it. Syntax error, I could see you loving this. This is the exact type of thing that you could use to like cook one of your calculus professors, okay? Boxing mind, that's wishes. That sounds really tough. I hope that you're able to I guess like make some progress. Um okay, so I don't know that that's true, Jasu. It doesn't seem true. If we were going with the same Stack Exchange thread here, like that seems way too simple. Oh, hey, these people are addressing the elliptical trig functions, just a scalar multiple of regular trig functions. Yeah, Papadoria. Yeah, that's to me code to be. I don't know what the fifth one is. I don't know if you're talking to someone else with that though. Not rectangularly hyperbolic? What the? I didn't know that they could be rectangular. I can't see whatever link you're posting code to be. I need you to just put the actual text into chat if you can. I think YouTube just doesn't really allow links anywhere, like unless you're a mod. Like, yeah, whatever link you think you're posting, I can't see it. Hmm. Oh, you want to go back? I think that was for elliptic or something. I was only half reading it. Uh, I think it had something to do with eccentricity, which is a property of conic sections. I think. Yeah, eccentricity. Cosine and base E? Oh no. Uh, I don't see it in the Discord code to be. Maybe it's just that's maybe that's you just joined now. I wish I could figure out this parabolic trig stuff more quickly, but I probably will have to move on once we get a different question in. Even then, like, it's not necessarily integral to figure out the area of that sector. I'm not opening up a Google Drive link. I'm sorry. That's kind of dangerous. It's I was from someone who I don't know. I'm not going to open a Google Drive link. It's go in 3 minutes. Oh, okay. I don't know about that Papa door yet. It's I Developer, the only place you can really do it is a Discord. The PDF directly in Discord. Uh, that feels safer, right? Does Discord check for? Uh, that I don't even know that much. $10. Okay, it does look like Discord scans stuff. Okay, I got it. So code to be. Which one did you want to see? The fifth one? Okay, the fifth one. Oh yeah, the image is the best. Thank you. I think it's we have to do the it's some area like I think it would be the area that's enclosed here, and for cosp it'd be divided by that horizontal distance. I'm not really certain of that though, or how you would define that area. The godly fizzbuzz double the parabolic cosine. Fizzbuzz is a god. I don't know if a parabolic cosine is within his powers. Maybe, but um developer, yeah, that should be okay. I just a little sketch up by Google Drive links in particular because I at least heard that they can have kind of anything on there. If it's just like a link to a regular website, though, that's fine. Um, so this is differential equations. Ooh, wait, what the hell? These are non-homogeneous. Oh man, I gotta dig deep if I want to solve this. It's been a minute. You have to go now. All right. Thanks for trying pop with me, Papadoria. But hope you have a good time. Uh, that's the matrix form. I forget how you do anything at all with this though. Um, oh, you could convert it to a second order ODE, right? I forget how you do it with the linear algebra. How do you convert it back? It's been a minute since I've done this. Developer, the easiest thing might be just math discussion. In Yogesh logarithms, yes, but you'll be third in line. Unfortunately, there's two questions that people have asked before you. Let y equals x prime. Um, and so, oh my God, there's Cook. As big as possible. So wait, um, I'm probably still going to do something wrong here, but the first equation would be that, and the second equation oh yeah, that does help the developer. Thank you. Oh God, that looks hard too. uh, you're next in queue for after this question though. Um, how do I combine these into just one? Oh my God, it's been way too long since I've done this. This feels stupid. I could solve that one for dx dt and plug it in. X prime is 5x minus y. Wait, but I'm getting confused. I still have two equations there. Solve the first equation for y, substitute into the second equation. Okay. Yeah, that's fair. I still have to remember to do it just like the straight up linear algebra way, but that's going to take me way too long to remember. Then we substitute it into 2. dy dt is the second derivative of x minus x plus 3, and then y we just said is e to the t minus 5x minus dx dt plus e to the 2t. Okay, there we go. I'm not going to do all three of these, by the way. I'll do like the first one, I guess, but I won't be able to do all three of these at once. I can do the first one, and then I can come back around and do others if there's time later, but this isn't a short question. I didn't do dy dt correctly. Oh, I should have taken the derivative of that. That'll just be the homogeneous part though, right? OB? Right, I don't remember exactly. Yeah, I should have dy dt is e to the t minus 5 dx dt minus d squared x dt squared. That's what dy dt is. Ugh. E to the t minus 5 dx dt d squared x dt squared. Okay, that's what equation 2 becomes apparently after you do that. Just group common terms, I guess. Five dx dt minus 5 dx dt minus 3 dx dt. Minus x minus 15x 16x e to the t plus 3e to the t is 4e to the t, so subtract it to the other side. Okay, hopefully I got all my terms collected properly. I think so. Let's multiply this through by -1, because all these negative signs disgust me. Oh, it is a repeated root, right? Oh, that's even worse. Okay, so let's get the homogeneous. That's going to be r squared plus 8r plus 16 equals 0. No, this isn't repeated. No, yes it is. Wait, yeah, that's repeated. Ugh. Now on the bright side, at least the 4 doesn't match any of the exponents there. That will make it even more disgusting. The number of icons next to Funbox's Twitch name is growing. It is, yeah. Electric Geek. Quick question. Are there infinitely many perfect numbers? No, there's 1,832.56812. Next question. All right, the homogeneous is going to be C1e to the minus 4t. And I think we just stick a t in front of the other one. Now we need to get the particular. The particular is definitely something. I think we just take this thing and stick a and b in the coefficients. I think we let y sub p equal a e to the 2t plus b e to the t. Let me verify that. Paul? Get Paul on the phone. We need Paul. Okay, 3 a.m. to understand math. Looks right to you? Okay. Paul agrees. Okay, so... Oops. Oh, technically this is x. I'm solving for x here. Okay, so we need x prime, x double prime. 2ae to the 2t plus be to t. At least we don't have any stupid product rules. 4ae e to the 2t plus b e to the t. Okay, and we're plugging into that bad boy up there. 4a e to the 2t plus b e to the t. Then 8 times that 16a e to the 2t plus 8b e to the t. 16 times a e to the 2t plus 16 b e to the t equals 4e to the 2t minus e to the, wait, 4e to the right to just t. That would have been very sad if I got the wrong answer because of a stupid mistake like that. Wait, no, we're good. Okay, yeah. All right, group our e to the 2t's. We have a 4a. We have a 16a. We have a 16a. Do we have two 16s? Yeah, we do. Group our e to the t's. We have a b. Really? It's all a's? Oh, that makes sense, yeah. Because there are no stupid stuff. Plus 8b plus 16b e to the t e to the 2t. Okay. Yeah, the live stream will live on my channel still, so you'll be able to go back and check it. So yeah, if you have to leave, I'll still like attempt your question, and the recording will be there. 36 a equals 4 question mark. Yeah. 25b. Wait. -1. That one equals 4. B is 4 over 25. You saw it too, Cook. Okay, so the solution for x is homogeneous. Plus particular. Uh, 1 over 36 e to the 2t plus 4 over 25 e to the t. And then to find y, we have to go back to our original thing. We let x equals y prime. Is that right? Or was it y equals x prime? Y is x prime. So we just take the derivative of this, and that's y. Equation 1, you have y in terms of x in dx dt. Oh, wait. Oh, you're right. I didn't do that. Never mind. We need to do what you're saying, Cook. You streamed over YouTube, use social streams so you can show both Twitch and YT chat to everyone. You can combine with Discord channels. Yeah, the reason is that Twitch specifically has a policy saying not to show other chats on the screen. They used to not allow you to multi-stream at all. And when they eventually allowed it sometime last year, or maybe 2 years ago, the compromise they made was, okay, you can do it, but you can't show both chats on screen. Completely stupid, and I hate it. And every day I grow more tempted to just do it anyway, and I probably am going to at some point. Um, so I've seen that Gold does it too, and he seems okay. So Jeff Bezos really likes monopolies. Yeah, I didn't have him pegged as a guy who would really like monopolies, but people can surprise you. Your treasures are being robbed of my toilet paper saving advice. That's very true. The people need to hear about waffle stomping to save money on toilet paper. It's important information. Um, minus 1 over 18 e to the 2t plus 4 over 25 e to the t. Oh my god. We are nearly there. How are we combining this stupid crap? Let's start with the C ones. Few geniuses are recognized in their own time. So we can just absorb the constants, or we can absorb the coefficients into C1 and C2. So really, we can say just C1 e to the minus 4t again. And we can just say C2 e to the t e to the minus 4t. I didn't take the derivative correctly. Ah! I hate it when you point out legitimate mistakes, Dr. Cook. I'd rather you just lie to me and tell me that I'm right. Plus C2 e to the minus 4t. There. I forgot about the product rule, right? Should learn it for the money and power. They don't care about political affiliation. Yeah. They'll go whichever way the wind is blowing. Dom does math Z. Gen Reaper does Daisy Z. Hope you're doing well, dude. Good to see it. Oh, okay, yeah, I forgot that now we have two constants in front of. Oh, do I actually have to care about the coefficients now? Or can I just make them new constants? I don't remember. Minus 5c1 plus 4c2. Or plus 4c1. Minus c1 minus c2 e to the minus 4t. Minus 5c2t plus 4c2t okay, so minus c2 t e to the minus 4t. Mental math, please save me. I don't want to actually write all this out. I think I'm doing that right. Is this uni math? Yeah, this is like third or fourth year. The XY solutions. Oh, true, yeah. Because C1 and C2 also appear in the solution for X. Unfortunate. Okay, let's think about e to the 2t now. Disgusting fraction math. So this is a plus 5 over 36 e to the 2t plus 1 over 18. So plus 7 over 36 e to the 2t. Yep. Okay, now e to the t. We have 1 e to the t. We have a minus 20 over 20, or yeah, we should keep the denominator. Minus 20 over 25. Minus 4 over 25. So it's minus 24 over 25. It's 1 minus 24 over 25. So it's plus 1 over 25 e to the t. Okay. Hell no, I'm not plugging them back in to check my work. I think this is the answer. This has taken an annoyingly long amount of time to the point where I don't want to check it. But this is the technique is right at least. It's been a long time since I've done one of these. At some point, I need to go back and relearn the linear algebra ways, because that's like one of my favorite things in math ever. But today's not that day. Okay. So I'm gonna developer has been patiently waiting. Unless you have a question to ask about this one, I'm gonna move on. Um, I can post it over in your Discord too. I mean, it's something that I want to like just do so I can remember how to do it for myself. But if I happen to catch you doing it, that might help me remember. As like the general chat, okay? Or maybe in math problems. I guess you tell me where you would want it. Oh god, general. Okay, sorry. I have a very bad habit of saying, "Is this thing okay?" and then waiting, and then saying, "or this thing." About the first one in particular. Okay. Thank you. Thank you. Okay. This was the next question that was asked. I just saw hexagons and was like, ugh, what is this? A, B, C, D, E, F. The small hexagon is a regular hexagon with side lengths x. Hexagon is enlarged, center F. Are you? Oh, okay. No, yeah, I get what they mean with center F. Okay, I was like, F is clearly not in the center, but they mean you enlarge it, keeping F as the center of that enlargement. I scale factor P to give hexagon F, G, H, I, J, K. Show the area of the shaded region in the diagram is given by 3 root 3 over 2 p squared minus 1 x squared. Oh, I'm going to do this some terrible way, and there's going to be a really elegant way. Okay, what's the area of a hexagon, of a regular hexagon? I could work it out myself, but why do that when I have Google? Area of regular hexagon. Yeah, see, I just derived the area of a regular hexagon, Fenvox. Isn't that great? It's a great derivation. Don does derivations. Yep. So that's actually kind of a... It'd be helpful knowing that in the exam. Or like how to actually do that derivation. Or do you mean just knowing the formula developer? I could figure this out. Now there's just nothing to actually do. Oh, you're right. That does kind of solve the problem. Okay, fine. We can derive it. Yeah, it's gonna be what actually. Oh yeah, I didn't realize it was be equilateral. Are they equilateral? I need to be convinced of that. I was thinking of doing right triangles, like Slim was saying. Either way, it should work. But basically, get the center of the hexagon and divide it up like a pizza. Territory is saying that apparently this would be an equilateral triangle here. I don't quite see that for myself. There probably is a reason why. Hey, Ane. They do? Okay. I'm just gonna do the way that I know will work, which is we can, it's definitely an isosceles triangle. We can definitely say that much, but I'm gonna divide it in half like that and get a right triangle here. Oh, can you show it with the angles? The the 360 divided by 6. Is that what you do? I just want to, if they are equilateral triangles, I just am trying to justify that. No, I don't know the angles here. There must be a way to figure out those angles though, right? There is, but I don't know that offhand. I'm gonna do it's probably the bad way, but the way that I know will work is just doing the right triangle way. I think that's the most straightforward thing to do. Like if I was in the moment in a test and I didn't have Google at my disposal, this is the way that I would do it, I think. Because there are a lot of forms that would help us out here to get us equilateral triangles, and that would save some work, but I wouldn't know that just offhand. Well, wait, this still isn't that easy. Okay, no, what we can do is we know that is x over 2. And if we draw all of these diagonals, we can draw a circle around here. So we know all these angles have to add to 360. And they're split evenly among these 6 slices here. So we know that any one of these angles is 360 divided by 6, and that's 60. And I'm cutting that angle further in half, so this is just a 30-degree angle in here. And now we know it's a right triangle, we know an angle, we know a side, so we can solve the entire right triangle. We care about the area of it. The area of just that right triangle is going to be 1/2 base times height. So 1/2, the base is x over 2. The height, we need to use trig, I guess. X over 2 tangent 30. So that's going to be x squared over 8. Tangent of 30, if you know your unit circle, is a number. 1/2 over root 3 over 2. 1 over root 3. Root 3 over 3. And that's the same thing as root 3 x squared over 24. And now we can argue that this hexagon is made up of 12 of these right triangles because we have 6 slices, all of them are cut in half. Hey, Pish. So we're going to take this and multiply it by 12. Why isn't that right? Why is there a 3 on top? That I have the base twice. No, I did that properly, I think. I'm missing a 3 in the numerator. That's my issue. I did rationalize it. I'm not getting the answer, though. Wait, 8 times 3 is 24, right? Yeah. I want to multiply this by 12 to get the entire area of the hexagon. But that's not right. Developer... Okay, yeah, you definitely... I just wasn't sure, so that's why I'm doing this weird right triangle thing. To be honest, I don't know what the area of an equilateral triangle is offhand either, to be honest. What? The area of a triangle is 1/2 base times height. The base is already x over 2. The height, x over 2. Really? Oh, I do. Tangent is opposite. Yeah, okay. Thank you. I was trying to do that in my head. It's because tangent of 30 is equal to x over 2 opposite over adjacent. And so I didn't rearrange that formula correctly in my head. It's x over 2 divided by tangent 30. And so that you get just root 3 then. There you go. Root 3 over 8. And now there's 12 right triangles. So the area of the hexagon is going to be 12 times root 3x squared over 8, and that gives us what we want, right? Yeah, 3 root 3 over 2 x squared. Okay. That's how you get the area of a hexagon, of a regular hexagon, I guess. And so developers, sound like you know how to justify that they're equilateral triangles. There probably is a quicker way of doing it than what I did, if you know that. But even then, figuring out the area of one of the equilateral triangles, I don't know a lot offhand either, so I would still have to do some work personally. Okay, but once we can justify basically that formula there, all we have to do is we know the shaded region. You get credit and not a Oh my god, Cook. I saw Academy's chat first, so I hate to break it to you. Now we just subtract the big hexagon from the small hexagon. So 3 root 3 over 2. This side is p times x for the big hexagon, in parentheses squared. Minus 3 root 3 over 2 x squared. And so that becomes 3 root 3 over 2 p squared x squared. I'm doing a lot of extra work here. Now you just factor out the x squared in the 3 root 3 over 2. And that's how you get the formula they got there. Okay, that one could have been worse. I was a lot more scared of that when I initially saw it. Let me know if you have any questions about that. Someone asked me earlier about logarithms. Are you still here? Yogesh, are you still here? Do you want to know about logarithms? I'll type their name in the YouTube chat. All right, see you, developer. Thank you for the question, for your patience. I don't know if I want to challenge myself. Okay. Do you actually need help with this, or are you just like challenging me? I guess I can try it. It looks really annoying. Um, Let me. It's a bit. Let me like crop it. We've done this one before? I definitely remember doing a similar thing where you make an isosceles triangle. And you find the area of like that little bit there or something. I don't. Sparkling new. The hexagon formula. Oh. Yeah. Oh, you have to do this. Or no, you have to get the... You get the area of the sector. And then you subtract out the little caps right there. Oh, and so yeah, so Fenvox is getting the quick way. Yeah, like this will be a lot harder on a like stress exam. Oh wait, do we know this is a hexagon though? Uh, how do we know that this angle here is 60? That's the question, right? SageWorks, I have no clue. Oh, it's equilateral. Because these are both radii of circle A of radius 4. And this is a radius of circle B. Okay, yeah, so I agree. This is a hexagon. So Fenlux is saying we can get the area of this cap by creating the entire hexagon and doing the circle minus the hexagon and dividing it by 6, because that basically creates 6 of those little caps there. So I think I like that. Now you can curse SageWorks, I don't care. Okay, so pi r squared 16 pi minus 3, what was it? 3 over 2 x squared? Yeah. We need, it's 4. Yeah, we need to do this first before we can get the area of the shaded region. How does math work? I think I did that right. Okay, so a third circle minus 4 caps. Oh yeah, I mean, I was just gonna get the area of the upper sector and multiply it by 2. I think I'm gonna do it that way because that looks easier to me. So 2 times the area of the sector is the angle in radians, right? And so it's a 60-degree angle in radians. No, times the radius. 4 times pi over 3. So r squared. The area of a sector. Yeah, it's theta r squared, right? We need 2 dimensions. That doesn't make sense though. Why is it times pi? Because it's radius? Am I bring it right? This feels wrong. Circle, sector, area. I don't know why this feels wrong. It's 1/2 r squared theta. That's why it felt wrong. I knew I was missing 1/2. When theta's in radians, at least. No, I don't stream it every day. I stream Tuesday, Thursday, Saturday on YouTube. And depending on your time zone, that might be Wednesday, Friday, Sunday. That's the area of the entire sector. We have to subtract out 2 of the caps. What an equation. But that's the final answer once we simplify that. See a developer? 16 pi over 3 minus no. (32 pi minus yeah. Isn't this negative? No, it's not necessarily negative. Because this turns to a plus. Is 48√3 bigger than minus 16 pi? Yeah, it has to be, right? Probably. I don't think it's much more than... I don't think it's a very big positive number. 48√3 minus 16 pi. Wait, really? I don't know why it's that much bigger. I thought it'd be a little bit more than 0. It's 48√3. I guess it's 48.5. I guess that's why. Or like 48 basically times 1.5. Kinda. Whereas that's just 16 times 3, which is about 48. Okay. That's how I do that, I guess. Oh, okay. I gotta clean up the million tabs that I have here. Frickin' parabolic cosine. Solve the same problem on the surface of a sphere? Oh my god. Wait, I still need to go through and pick out some problems for us to actually work on. I've got to like read through it. You might just do like 1 or 2 linear algebra questions. and call it, I don't know. My brain's gotten to the stage where it already feels like it's like crashing, so I might not even be able to handle this. Quick and recommended. Suppose A is a 4x4 identity matrix with the last column removed. A is 4x3. Project B equals 1, 2, 3, 4 onto the column space of A. In permanent days right now because of all the hurdle. That's how I felt after each reading session. Non-Euclidean geometry is so messed up. And like, it's only slightly non-Euclidean too. But also, measuring time in terms of distance is also just crazy. The very last section talks about that in particular. Yeah, the longest distance between 2 points is a straight line. So that's only for time-like separated points. Hey, color cone. If they're space-like, then it might be a straight line. It depends how they're separated. Okay, let's look at 13. It's going to be AA transpose over A transpose A. Where am I doing this? Look at all the math we've done today. Okay, I was going to do it down here. That's not enough room. Actually, you know what I can do? Just insert a page there. Okay. So A is the 4x4 identity with the last column removed. Like that. The projection matrix for A is A transpose over A transpose A. Wait, is that right? It's still a string text, yeah. I want to get through all the lectures that he's done because I haven't watched any of the lectures in like at least a month now. Hopefully I can do that over the next like 2 weeks or so. And then I was planning to get to a more advanced linear algebra book, but I might switch gears and go to complex variables. Because I'm really going to need to know those two. Oh wait, this is the formula I need. Yeah, complex analysis. Was your favorite course in undergrad? I wish I took a course on it in undergrad. I have not, and I think I'm gonna suffer for it. So the Jim Sean pretty Eagle song when screaming starts to get on nerves. Yeah. That typing is just isn't for everyone. I really like it, but I think I have that book offhand. I've heard other people recommend the same one, so this isn't quick or well, it might be recommended, but this isn't quick, right? To get this, there should be an easier way. Onto the column space. Do I just multiply b in? Let me check. Do I have it? Uh, ooh, that looks like it. Yeah. How long? 719 pages? That's a lot of pages. I don't know what'll be. I have no clue what the importance of complex analysis is. I don't know how far I would. Oh my god, dude! How long of a preface is there? I don't know what would be important to get through. Actually, I can figure out what will be important to get through. Um, Loxodromic transformations? That sounds like a medicine. Um, yeah, so I've decided on a grad school. I've accepted the offer and I put the enrollment deposit down. Um, so in fall, I'm going to be going. Actually, I haven't announced before, so if you're hearing this, this is the first time I'm saying this, but I'm going to be going to University of Washington in Seattle, and I'm looking at the classes of for a master's in applied math, and so I'm going to have to move up there. But sorry, I'm in California, and I'm looking at the classes I'm going to have to take, and in the first quarter, there's going to be complex analysis, applied complex analysis, and they don't start from scratch. And I've never taken a complex analysis class ever. And I'm trying to figure out. I was looking at the course description. I think the first thing this is like branch cuts. That's pretty early, and I don't think those are. I don't understand what a branch cut is. Is that bad? I don't think. Thank you, Fenbucks. It's really annoying. I haven't been like telling people because I still haven't heard back from the place I applied to for physics, which is University of Oregon. I'm just gonna say it because I don't care anymore. They said they would get back to me by March 15th, and it's April 22nd. And I've emailed them multiple times asking them when I can hear back, and they never got back to me. So the deadline for Washington came up, so I just took it. Yeah, so I'm doing a master in applied math, and they have two tracks of courses. One is just a regular set of courses. The other one are the PhD level courses, and I want to do the PhD level courses. So uh, I let me find it. Not a full on syllabus. Uh, where I can show this. It doesn't matter. Thank you, Jed. Used to do one every year. Oh wow. Yeah, dude. If you want to get like lunch or something, that'd be awesome. If you ever were around there. Dude, where in the I found their course catalog before, but it's like hidden somewhere. Complex analysis and applied sounds like an oxymoron, Territar. I mean, I don't know how you apply complex analysis, but I think complex variables have a ton of applications in general. Is it in here? Courses. There we go. Bottom, I think it was 5, 6, 8. No? 5, 6, 7? Yep, applied complex analysis right here. This is what I'm going off of. So branch cuts, I know the bare basics of. Series, I don't know in the context of complex variables. Product expansions, no freaking clue. Contour integration, I've heard of, and I maybe have seen it once. Numerical, numerical relation knows. Harmonic functions, no clue. Complex potential and singularities and physical problems. I might have seen that without knowing it. That might be something that E&M alluded to. Conformal mappings, sort of, from Penn Center's class. Oh yeah, Jed, thank you. I didn't know those streamers existed. Wait, the Laplace transforms have to do? Laplace transform. What's complex? S is a complex number? Oh. Really? I've derived Laplace transforms and never had to do anything with complex numbers. I said I remember. Maybe this also work in complex numbers. I don't know. But yeah, so this is gonna be like the first quarter for me that I'm planning to try it. There's an easier version of the class, but I'd like to do the PhD level classes if I can. Laplace transform maps complex numbers to complex. Fourier maps real to complex. Oh, that's interesting. I've never heard them describe it. I saw them separately, and I was only taught how to get them, not anything about the theory of them. That's interesting to hear, Territar. This is the easier version of the class. That's just like the master's level, which still sounds really cool, but you think it'd be fine to learn it? Yeah, I think it's a good few months. Like, it doesn't start until late September. So I have time to prepare. The other ones I wasn't that. This was the one that I was the most worried about. The other PhD level courses. I always feel stupid when I look at quarters. I don't think the other ones sounded as scary. Yeah, advanced methods for ordinary differential equations. I feel like I can figure this out. It's gonna be. I'm not saying it's gonna be easy, but ODEs. I feel like they can't be that bad. Maybe I'll regret saying that, but that'll be the second quarter, and then because there's only 3 like classes that have this like master's PhD duality, and it's one in each quarter. What's the one in spring? $569. And oh yeah, this one makes me a little nervous. But that's in the future, you know. So quick, I just said that yeah, that's my future math classes. I've accepted an offer of admission from University of Washington in Seattle for a master's in applied math, and I was just talking about the stuff I'm going to try to cram in time for that. And so, yeah, the place I applied to for a physics master's, they just never got back to me. They still haven't. And the deadline to accept or reject for or to accept the offer from University of Washington was like last week. The instructor proving the Cauchy integral formula after 3 courses would be like, well, I proved the main theorem, and the rest of the course is the application of Cauchy's formula. Well, that could be that could be really good or really bad. I don't know. Well, the only one that I know, well, I'd have to look. It's pretty flexible, but this is the one I know I'm gonna try to take. The this is a PhD level class. I was explaining that in order to get a master's in math, there's only 4 mandatory courses, and 3 of those mandatory courses have a master's level class and a PhD level class, and I want to try to do the PhD level classes because it'll look better when I try to apply to stay with them for a PhD, which I'm planning to do. I think I could do physics classes as an elective. I don't know how it would work, but I'd be interested in doing that. Oh, they have a chart somewhere. Where is it? No. I don't know yet. I only know what one of the classes is gonna have to be. Dude. I hate how university websites are laid out. It's the most confusing thing ever. Okay, here, this is what I want. These are the full wait, is this the one that... No, these are my degree requirements. And so we're just... This is the one that I know I'm going to take in the first quarter. We're just looking at 567. That's the complex things. What's up, Simply Facts? What's your question? I need to get rid of a bunch of those crap. I have too many tabs open. On campus, yes. So I'm moving to Seattle over the summer. Thesis option, I don't know. Probably not. I know. Okay, so what I've seen online is that thesis looks good for a PhD, but this entire program is 1 year, and I think by the time I could even start working on a thesis, I would have had to already submit my application. So I don't know. That's what it seems like. I don't know. I haven't looked into it that much. Yeah, I don't know how, or I don't know how it's gonna look, but I love streaming, and I would love to just do this as my career if I could. I don't see myself stopping streaming for a long time. It's not going to be the same frequency that I do right now, but I'm not just going to stop. Yeah, Something Facts, just tell me what your question is. Are you in the Discord? Can you just put a screenshot of it? Actually, there's 581 and 584 are interchangeable. I don't know what quarter of those were offered in. No. What quarter am I even on? Spring? Scientific computing. Oh, Carrot. Thank you so much. Get some sleep, dude, but I appreciate you saying hi. Numerical differential equations. I think this will be cool. I don't feel like it'd be that bad to actually do. I've done numerical analysis before. Yeah, I think that'll be a cool class. I I do know that I could also do 584. Numerical linear algebra. Yeah, that also sounds interesting. You'd be worried to be redundant, really. Why would it be redundant? Let me the random and it just looks weird simply because it's a random string of oh, it is a real thing. Uh it just looks weird. And no, I don't trust random people on YouTube. I don't know which one I should click on. This is just this mark scheme. Subative algorithm sounds interesting. Where was that? $505. Oh yeah, fluid dynamics would be cool to get into. Oh, subative algorithms is there. 7. I've never knowingly studied calculus of variations. Maybe I've seen it without knowing it though. You're asking about part D specifically. Whether Lagrange talked on Saturday as a topic in calculus of variations. Okay, interesting. Okay, so I think I understand enough to do this problem. I don't think we need the results from parts A through C at all. No, what, okay, no, I'm good. I do need the result from part C? Okay. Oh, you're right, I do need, so you're giving me that capital T is 27.04. What a terrible 4. Do I need K? I probably need K though, don't I? Oh, K equals 2.6 from part B. Okay, cool. So yeah, I'm gonna start by finding the velocity. And so you're asking why we don't need the plus c. Let's start by including the plus c and seeing what happens. So velocity is the integral. We're gonna need, this can be like a piecewise function, I guess. So let's start by integrating the first function, 0.3 t to the 1/2 dt. This is only valid for t's in a certain range. We're going to get 0.3, I hate decimals, 3/10. And we're going to add 1 to the exponent and divide by it. So times 3, no, times 2/3. What? Oh my god. T to the 3/2 plus c. So that just has to be 1/5 t to the 3/2 plus c, right? Okay. So the particle starts from rest. So you have to, when you read those words, you have to know that v of 0 is equal to 0. That's what that means. So we can use that fact to figure out what c must be. Yeah, exactly. So here we don't need c at all. Because they're asking for distance traveled. They're not asking for location. It's going to be a definite integral. Oh wait, for the second equation. Well, okay, so when we do the second equation, yeah, so like well, once we integrate velocity, we don't need plus c because it's definite. And the second equation for velocity, we definitely do need plus c, but we can figure it out from the first equation, what that c should be. Uh, 2.6. What is that as a fraction? You know, it's like 2 and 6/10. I literally taught this in like 5th grade, or probably before that. I don't know when you learned for fractions, but like you do 10 times 2 is 20, plus 6 is 26. So it's 6/26. I did that wrong apparently. 26/10. Yeah, it's 26/10. I just got the result wrong. There we go. Add 1 to the exponent, divide by it. So that's times -2 t to the -1/2 plus c. Yeah. Okay. So we can figure out what this plus c is because we know that this thing right at 4 should equal whatever the previous equation was at 4. Like we want this thing to be continuous. It wouldn't make sense to have a sudden like jump or like a discontinuity in the acceleration without something extra happening. But we don't have anything extra happening. So this you get? Okay. Then I need to figure out what c is here to be able to figure out the distance part. So I need to go through and do this anyway. If we plug in 4 to this, it should equal plugging in 4 to that. So 26 over 5. 4 to the negative 1/2 is 1/2. Plus c. c is -1? Okay, thank you. The integral looks terrible bits, brew. I'm probably not going to be able to solve it. Unless there's some like trick there, but it looks like I don't know what that looks like. Okay, so if we want to find distance between 0 and t, we need to integrate the velocity from 0 to 27.04. The issue is that we have two different definitions of velocity here depending on t, so we need to split up into two integrals. One goes from 0 to 4 of the first function. The other one goes from 4 to 27.04. That's right. Okay, good. And so we don't get any c's here because these integrals are definite. Like we have limits now. So that's basically why we don't get a plus c. We're going to add 1 to the exponent and divide by it. Be 1/5 times 2 over 5. T to the 5 over 2. From 0 to 4. Okay, if that's all you needed to hear, then I'll stop there. But yeah, like you integrate the inside and then you plug in the bound. But it's in past paper question. Remember they found C. We don't have enough information to find C unless we know where point O is. We need to know our starting point. Thanks so much, Bitsbrew. Appreciate that. Can you find no distance when t equals 4 in both equations? Yes and no. So if you want like a distance function, let's say like this was an indefinite integral, t to the 5 over 2. I'm going to be careful here and say this is c sub 1 because we get two different constants. Like we can't assume these two integrals are going to result in the same constant. This thing is going to integrate to 52 over 5 t to the 1/2 minus t plus c2. So what we can do is we can get rid of c2 by doing what you're saying. Well, they're saying point O. Like if they use O to mean the origin, then sure. But I don't know. O might just be an arbitrary point. Okay, if that's the convention that the test uses, then I guess we can. As long as we know the starting point, then yeah, we can find it. Okay, so yeah, in that case, then we can definitely find C1 because we would know that D of 0 is 0. My choice, I shouldn't have used D. I maybe should have used X. Oops. Because this is the actual position that we're talking about now, not just distance traveled. And so, yeah, you could just find that C1 is 0 there. And then you can do the same thing we did with the velocities to figure out what C2 is. If we didn't have this piece of information here, the best we would be able to do is get rid of C2, but it will be in terms of C1 still. We would still have a constant. It'd only be one constant, but yeah. I am a tutor Bitsbury. I'm about to start on a master's in fall. When I know when to use C and when to not. Well, we never even needed to worry about C for the distances because like the rule is if your integral is definite, you don't need to worry about C. If your integral is indefinite, you do need C. And whether it's definite or indefinite depends on the information that you're given. Another way of thinking about it is distance traveled is a difference. Like, distance traveled is your final position minus your initial position, the absolute value of that. And anytime there's a difference, you don't need to worry about plus C because like these x's come from the same function. Like, let me, like, we can literally just like use this as an example. Let's just say like, distance traveled between t equals 0 and t equals 2. It's going to be x of 2 minus x of 0, absolute value. And so we can even forget that we have that initial condition and just literally plug in 2 over 25 times 2 to the 5 over 2 plus C1 minus 2 over 25 times 0 to the 5 over 2 plus C1. These constants will always cancel because it's a difference. Oh, that might be displacement. No, I think this is distance. Maybe I'm wrong. Color cone, I would, but there really aren't that many resources. I'm gonna be relying on loans, unfortunately. But yeah, so simply facts, like what I'm trying to say is that the plus C is always there. It's just that when things are a difference, the C's will cancel anyway, so you don't really need to worry about them. So if you're asking about absolute position, we definitely need constants. If you're asking about distance traveled, which is basically a difference of two positions, you don't need constants. Okay, no worries. Isn't distance always positive and displacement positive or negative? That's what I was thinking of at least. In Bitsbury, if you're asking why we need C in general, it's because integration is the opposite of taking the derivative. And when you take the derivative of something, the constants just disappear entirely. Like you kind of lose out on that information. And so if you do integration, you need to add that constant back in, but you don't know which number in particular it is. So yeah, when it comes to like the scholarship stuff, I have worked out the finances with a combination of loans and going through the last of my savings, I think I can do it. The thing that saves it is that it's a 1-year program. So while tuition is somewhat high, I only have to pay 1 year of it. And so even compared to like my local state school, um, that I assumed would be cheaper, it's actually kind of not. Or like, yeah, like my local state school should be cheaper, but because University of Washington is just a 1-year program, it thankfully could be it could be a lot worse. I guess I better actually complete it in 1 year, but yeah. Federal scholarship for grad school? No, there's very few resources. I guess when I've looked, there's way fewer resources for grad students in America. No worries. Simply facts. So yeah, the loans we get are worse. As I mean, I would need to actually check that, but like the loans that I took out for my undergrad are literally like half the interest rate of the loans that I'm gonna take out for grad school. It's like 3% versus 8% or 4% or so. Um, and scholarships are like a school dependent thing. And I specifically was not accepted to the funded version of the master's program in University of Washington. So when I was showing, I didn't realize this until I went to like visit them and talk to the I forget what her job title is, but the person who knows about this stuff. I asked her what the difference is between applied math and applied and computational math, because it looks like there's just one class of a difference. But she said that the real answer is that these classes are interchangeable. The only real difference is that applied math is funded, and the one that I got into is not funded. So, yeah. For motion in a straight line, you have to make sure velocity doesn't change sign. Oh, it's the absolute value of velocity, right? The integral of the absolute value of velocity. Or speed, same thing, yeah. Okay. Oh yeah, you're right. So I think I was talking about displacement. Oh shit. Uh these are both positive over their intervals. Okay, so thankfully it didn't come up here. But both these functions, I think I'm covered by luck. The velocity is always positive. But yeah, I should remember the absolute values. Linear and quadratic functions are brar? Yeah. Free to ask your question. I can like be more specific. Can we have a few research funding programs we can apply to regardless of which Canadian university you're going? Oh, I don't think we have that here. Definitely not from the federal government. There are like third-party organizations that you might be able to convince to fund you or give you some funding. Um, I haven't seriously looked into it, but I imagine it's pretty competitive, and all the programs are geared towards like specific types of students that I probably don't fit into those categories. Um, I don't know though. I haven't like looked into it for myself. The shot that I potentially have is trying to apply to be a TA or some position that has a tuition waiver with the school. Um, I probably won't get offered one through my department, but apparently you can apply in general to be a TA. Um, but that's kind of like the main hope that I would have of not paying tuition. Grad school in the States. Recently learned that grad school in Canada doesn't waive tuitions, which is weird. Grad students run strike because of that. Huh. Yeah, I don't know how it works in Canada at all, to be honest. Whether it's generally free or not. For a master's. I applied for a PhD, got accepted for a master's, and I'm hoping to, hey, it's G1. I'm hoping to, like, apply internally to stay on for a PhD after my master's. Artists later, you had to pay some fees, which you thought were stupid. Like, was it? I mean, when you say fees, like, I'm gonna have to pay fees for, like, I forget what they're called, but, like, there's a bunch of, like, fees that are, like, between $0 and $200 for, like, it includes, like, a bus pass, and, like, there's, like, a student club fee or something, like, fees like that. If it's less that, like, I could see the fees being potentially reasonable if it's like that and they're on the order of $0 to $200, but if they become like thousands of dollars, then that's just becoming tuition again. Applying to most scholarships you can, the more scholarships you get, the easier. Oh, really? I didn't know that they would like snowball like that. Something called excellence fee? That sounds like such bullshit. Snowball's hard? Okay. I remember as an undergraduate just looking in general for scholarships to apply to, and it's kind of rough out there. It was a lot of work to put in even one application, and they were all very competitive. They established it during the financial crisis never got rid of it. Huh. Into organizing seminar and lecture group in your grad programs. Oh yeah, they have like it's called like a journal club or something that they have. Yeah, bro, I think I can do that. Okay. Yeah, we can definitely handle this. I think putting your CV the more attractive your PhD and scholarships. Yeah, fair. Something the stream would be a really strong point in my favor for applications, but maybe it was, but there were two pretty big weaknesses in my application. Hey, Anders. So I don't know that I like made up for it. Okay, so Abrar. The first thing, the thing that's easy to tell here is whether it opens up or down. The way we figure this out is by looking at what it's called the leading coefficient. Basically, look at the x squared term and look what's in front of it. Here, it's basically a positive 1, even though we don't write it. And so because the leading coefficient is positive, I'll actually write this out. The leading coefficient is positive, so f of x opens up. So positive opens up, negative opens down. So finding the vertex and axis of symmetry is going to take a little bit of work. I'm going to save that for last. The x and y intercepts are a little more direct, so let's do those next. So the thing to remember with x-intercepts is it's where it hits the x-axis, which actually means y equals 0, or f of x equals 0. So we take the entire thing and we set it equal to 0 and solve that. To solve this, you can do the quadratic formula or you can factor it. I like factoring it because I kind of set up something that looks like this because I know x times x will give me that x squared. So we have to figure out what goes in these slots here. They have to multiply to positive 9 and add to negative 6. So the options that multiply to 9 are 1 and 9 or 3 and 3. And I noticed that plus or minus as well for all these. I noticed that negative 3 times negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. So this is how that factors. So we just end up with one x-intercept, or like, we can split off into two equations. Well, no, that's that's unnecessary. Let me that's kind of a weird thing. It's just x minus 3 twice. So let's just worry about x minus 3 equals 0. Normally you would split off into two equations, but it's just the same equation twice. So let's just worry about one of them. So x minus 3 equals 0, so we get x equals 3. That's our x-intercept. We only get one, and that's okay. The y-intercept is where x equals 0, because that's where the y-axis is. So f of 0 equals 0 squared minus 6 times 0 plus 9. These are both 0, and so we just get 9. Okay. Oh, you know what? There's a trick. There's a little bit of a trick. If they ask where the x and y-intercepts are, they sometimes want the actual point. So the x-intercept is at the point 3, 0. It's the x value we found, the y value is always 0. And for the y-intercept, vice versa. X is always 0, y is the point that we found. These are the actual intercepts, and depending on how picky your teacher is, that might matter. Sometimes x equals 3 or y equals 9 is good enough, though. This is the safe thing to put the actual point, though. That's always right. Okay, now let's work on vertex and axis of symmetry. So for vertex, we're going to need to find the vertex form. And we do that by completing the square. So when we complete the square, we use a trick that's basically plus something minus something. And this is it's the type of thing that's easier to understand once you've seen it once. Oh, you're right, it already is a square. Thank you. Never mind. So we would complete the square, but we already found that this thing is x minus 3 squared. So this one is actually one of the rare cases that's very easy because it's already x minus 3 squared. That's what we found when we were looking at the x-intercepts. And that's why I got held up for a second, like splitting off into two equations that were the same thing. So we got lucky. We don't have to actually complete the square here because it's already a square. And so the general vertex form is f of x equals a x minus h squared plus k. The vertex is at the point h comma k. So here the vertex is going to be h is 3. Remember, it's x minus 3, but this formula has the minus sign built in. So it's at 3, and then there's like an invisible plus 0 here. That's the k. So 3, 0. Okay, finally, the axis of symmetry. The axis of symmetry is pretty straightforward. It's wherever the vertex is. It's a line though, so it's a vertical line, and vertical lines look like x equals something. So it's just x equals 3, because that's where the vertex is. Oh, thank you, Abrar, for the kind words. Okay, so now let's put all this together and make a graph. We have the point 3, 0, and we have the point 0, 9, basically. We know that 3, 0 is the vertex. One, two, three. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 0, 3 is the vertex. Sorry, 3, 0 is the vertex. 0, 9 is the y-intercept. And we know it opens up. So let's just play connect the dots. Opening up. And then mirror it over here. I'm not being too exact with this, but this is the idea. And if we want it to be fancy, we could draw on our axis of symmetry. X equals 3. Yeah, that's how I do that problem. Let me know if you have any questions. Thank you for the kind words. Anders, I hope you're doing well, by the way. It's good to see you around. Could I give this? I can zoom out if you want to take a screenshot of or something. And the recording will be up on YouTube. I don't have a easy way to like give it to you though. And Ariane, I saw you put part of a problem there. Sorry, because I didn't address it. But it seems like how the problem is cut off there. Oh, thank you for the 1 bit, but I don't have TTS turned on. To be honest, a lot of the TTS voices kind of annoy me. I'm looking in the YouTube chat. There's 2 questions that have just been put there. Sachi in 1 question. I don't. So the chat that's up there is the Twitch chat. I dual stream to Twitch and YouTube. At some point, I might just start showing both. I'm not supposed to show both. There's a rule on Twitch against it, but I might just start doing it. If you're talking about sending me a screenshot or something, you can put it in my Discord server. Okay, so 1 question. I bet someone around here would know the answer. I don't know offhand, to be honest. Well, I know that n factorial is better than 2 to the n. I don't know where n to the log n. Oh, wait, no. I don't know where n to the log n fits in, though. And then the second question will be from Sachi. How to learn integration. Shushruth. I'm probably saying it wrong. I'm sorry. It's just a lot of practice, unfortunately. If you want like a nice quick explanation of things, I do really like Paul's online notes. I'll give you a link to this in a second. But it's like look in the sidebar for whatever topic you're stuck on. Maybe you're stuck on this part. Like integrated parts, trig functions, trig subs. And just like look at the practice problems there. Hey Zeri. How to find upper lower bound? I need a more specific question than that. I'm sorry, I don't know how to answer that. For one question with asymptotic growth, how do you compare? Can we think about e to the n ln2 and e to the log n ln n, I guess? This feels weird, but I do feel like n ln2 is going to grow faster than log n ln n, which would lead me to believe that n log n would be on the short end of the stick here. And I do feel like the exponent is more important than the base in the long run. And n grows faster than log n. So one question, I think this is the answer. I'm not that confident in it though. I'm a tutor, Zeri. Okay, let's think about Sachi's question. You didn't quite get the logic? Okay, yeah, so let me try and explain it. I just noticed that 2 to the n is the same thing as that, and that n to the log n, assuming that log is base 10, is the same thing as this. And the whole purpose of doing this e to the power thing is so I can just compare n ln2 and log n ln n. Because these e's aren't really relevant to the asymptotic growth because they both have them. And comparing these two things, like this is basically linear and this is basically a log squared. And so even if you square a log, you're not going to outrace a linear function. And it's not quite square, like, I mean, you can make it look like a square. That's kind of how I thought about it. I don't know if there's a better way of thinking about it. But, yeah. And the other bit, that n factorial is greater than 2 to the n, is just a bit of knowledge that I happen to have, so I assume that wasn't the issue, though. Yeah, no worries. Glad to help. You don't think any of the choices could be right in Sachi's question? Maybe we should graph it. Yeah, Anders, it's just Sachi's question there, and then that's it. I'll probably call it after your question, but... Okay, so we're gonna have a tangent. It's definitely an obtuse angle. Oh, none of these are obtuse. The biggest option we have is pi over 2. So we can solve the question. I don't think any of the options are going to be right, though. I think we can safely treat this as y equals 2 root x. Because both tangents should be on the upper part of the parabola. So y prime is 1 over root x. Then we set that equal to y1 minus 4 over x1 minus 1. That's the trick with these. Rise over run. And we know that well, and we know that y is 2 root x. Now we solve this for x. We should get 2 answers. X minus 1. I'm going to cross multiply. This is basically a quadratic. Root x is equal to negative b plus or minus 16 minus 4 over 2. Then we have to square it. That's annoying. Haven't you given me the exact problem before, Cytos? I forget how we did it. Or someone has given me that exact problem before. Okay, I'd definitely seen it before. I remember not being able to do it, but someone was able to. I'm gonna wrap up the stream before I can think about it though. My voice is really fading. So we have the points 2 plus root 3, comma 2 root x. 4 plus 2 root 3. And 2 minus root 3, 4 minus 2 root 3. Okay, so we also have the point 1, 4. We need the angle between them. So I think what I want to do is take each of these, subtract 1, 4. And then that gives us vectors. Then we can dot the vectors. And then so we get the angle. So I'm going to do that minus 1, 4. Do x minus x, 1 plus root 3, 2 root 3. 1 minus root 3. 2 root 3. Okay. Take that. Dot it with that. Set it equal to, what's the magnitude of that? Ugh, it's annoying, that's what it is. It's Wolfram alpha. One plus root 3. Square root 1 plus square root 3. Squared plus 2 root 3 squared. That sure is a number right there. Check signs. Is 2 minus root 3 negative? Is that the issue? No, it's not. I don't see what I'm doing wrong. Go to Desmos. Oh, that's not good. How is that possible? Is the dot product 10? I have no clue. I got a point that's not on the parabola somehow, and I don't know. Oh, wait. Oh, ha. You are squared. That looks better. I dropped the squared on the x values. Ah, annoying. Two plus root 3 squared. What is that? Wolfram? Seven plus 4 root 3. How about minus? 7 minus 4 root 3. I probably should have known that. Okay, then what do we get? Okay, now we dot those. Oop. Let's look for the dot product first. Zero? Really? And is this zero? That is a fat zero. That makes no sense. Oh, hey, Fahim. Thanks so much. Since you're on the Twitch side, there's a whole bunch of people who stream math on Twitch who you might like. In case you're interested in more streams like this. And Anders, I saw your question. Hopefully I'll get to it in just a minute here. Yeah, there's no way they're perpendicular, right? You're a brar. Oh, nice. Welcome in. That does not look perpendicular. If the magnitude of two vectors are given, how can we find the magnitude of the difference of two vectors? I'm not sure you can, because it depends on their direction, Amal. If you know the angle between them, you might be able to. Maybe $10. Fahim, I'm doing one more question after this and I'm wrapping it up. I've been going for way too long. What day is today? Actual Education might be streaming like right now. You could try him. He was in that list of people. The angle between them is 0, they'll be equal. If the angle between them is 0, then they're pointing in the same direction. And the difference in magnitudes is just the difference. The magnitude of A minus B is just magnitude of A minus magnitude of B, or the absolute value of that. Yeah, Polidori, I'm wrapping up this question. I'm going to work on another one, and then I'm done. I'm getting a result that makes no sense for this one question. Hey, Fizzbuzz. This is the original problem here. Lurkers, welcome. And so I'm getting that the angle is 90 degrees, but it doesn't look 90 degrees at all in the graph. And so, and Desmos, this is 1, 4. These are the 2 points I found where the tangents are. And just mentally connecting these lines, it does not look like 90. But when I do a dot product, I get 90. So maybe it's just I'm reading the graph wrong. Yeah, like the dot product is 0, so I my voice is really like hurting. To the person that's the question, as far as I can tell, it's D, but something seems wrong with this. It doesn't visually look like D, but I'm getting in the math that it's 90. Um, I want to look at Andrew's question though and wrap it up because I don't have many words left that I can speak right now. um, I don't know if it's standard, but my thought is to look at consecutive terms. Thingies. uh, I miss Dan's streams. I'm thinking we could like just look at a sub n plus 1 minus a sub n, and then uh, just add a sub n over to the other side. That seems kind of cheesy, but it might depend how the sequence grows as well. No, not every day. I do math Tuesday, Thursday, and Saturdays, and depending on your time zone, that might be Wednesday, Friday, and Sunday. Cheesy um like not a good solution, but it works. Like this doesn't feel. I think this is technically true, and this is a recursive. Well, uh, no, this isn't good. I don't think that. Yeah, uh, I I'm a American. I don't know if I like that. We could look at division rather than subtraction. I don't know if that'll be any better. But I'm looking at like different ways of doing stuff like this and just bringing the a sub n over to the other side. That's my idea. I don't know if it's good or not. I imagine there's multiple ways. Or, I mean, maybe not. But I do wonder there's multiple ways to define a recursive sequence for the same closed form. I don't know. I think I'm gonna have to Google. Cosine is a messed up sequence, but what are they doing here? I guess this is basically what I was doing, done a bit more carefully. Everyone's talking about the reverse direction. Oh wait, this might be it. I'm not gonna take any more questions today, I'm sorry. I gotta wrap up the stream after this. Hmm. I mean, I guess this is it. Like, lowercase a sub n is the new sequence. This might just be it. And there's that. I think people are just more interested in converting recursive to closed form. Or like that's usually like usually people prefer closed form, I guess. This is the one thread that seems like it's about closed to recursive. And I mean like no, Fahim, I'm not going to do any more questions today. I'm losing my voice. Once I wrapped up this one, I'm going to end it. Yeah, I think this is just what you would want. I can't think of a different way that you would do this. Gold, thank you so much for the raid. Um, Welcome in, everyone. How's your stream? I'm Don. I've been going very late today. I'm not going to stream for a lot longer. We're trying to wrap up a few last questions here. In 2 days, Fahim. For anyone on my end, please do check out Actual Education. He's awesome. Working on this question from Anders, and then we're gonna get back to a question we worked on before from Fembox, or not from Fembox, but that Fembox just commented on. The points of tangency. 7 plus 4 root 3, 4 plus or minus 2 root 3. Yeah, I agree. For the angle between the two tangent lines, I took each of those points, subtracted off 1, 4 to make it a vector, and then I dotted those two vectors, and that's where I got 90 degrees. Okay. So it's basically what I was doing here. Anders, where if we want to make it recursive, actually, there's definitely multiple ways to make it recursive because you could do like a second order recursion or something. My y values are wrong. They match yours, don't they? Oh. Okay. I don't see how, but okay. Same time, Fahim, yeah. Um, I was thinking about it, Anders, in terms of like I lost a negative on the second one. There is a negative in this one. It matches what you put though, doesn't it? Oh my god. Negative. I see. Okay, we can fix that. Uh, After them. Okay. So, Andrews, I'm thinking about in terms of if you have a sub n and you want a sub n plus one, you can either find it by looking at the difference or at the ratio between terms. And so that's why I started off by doing like, yeah, like a sub n plus one minus a sub n equals that. This just, it kind of feels bad. Making it recursive like this. But yeah, it can look at like successive differences or successive ratios. But I was saying it feels cheesy because it doesn't feel that sophisticated, I guess. Or like there's secretly some kind of like, cancellation or something. But these are technically recursive. Um, you do have to give the initial values, of course, but that's fine. Um, Things could get screwy if you wanted like a second order recursion, like involving an a sub n plus two. I don't know what you I don't know how you would do that, but at least if there's a sub n plus one and a sub n, I think this is the only thing I can think of for a general way of doing this, going by ratios or differences. And that's what that stack exchange thread was saying as well. I guess it feels cheesy because it's not computationally any easier. If you're calculating this, it's, if anything, harder to calculate that or that. That's what I don't like about it. It's not saving any calculations. Uh, I'm not sure if it would work. It's the ratios definitely seem like they'd be weird. Um, Maybe with the differences though, you can work something out. I'm not sure how that would look though. Hey, Recky Rec. Welcome in. Hope, hope you're doing well. Um, so what's up with this? See, I think it's best I can do for you, Anders. Like I say, I can't think of a better thing. I might just try and finish off this text form from before. In Terari, I'm not going to take any more questions today after this. I'm sorry. I've got to get going in a minute. The integration depends on the asoden in the previous terms. Mary, hey, how's it going? Uh, oh, I mean, you have to say it's equal to something though, right? I guess you can say it's always equal to like that. Or like, oh yeah, okay, fair, fair. Okay, yeah. I think I see it now. Yeah, I'm about to get going, Mary. People have been asking really good questions. I'll be getting distracted, but I'm losing my voice, so my body's gonna shut down even if I want to keep on streaming soon. Okay, so wait, that's the dot product. So to minus 24, magnitude of that, that's a job for Wolfram Alpha. You know, I'll just put the entire thing into Wolfram Alpha. Arc cosine minus 24 over square root 6 plus 4 square root 3 squared plus 2 root 3 2 square root 3 squared times 6 minus 4 root 3, just flip the signs. In theory, this is the answer. $120. Is that what you got, 2 $10? Oh, you didn't say your answer. What is 120 pi 4 pi over 3? Yeah, 4 pi over 3. So the answers are wrong. Did you guess a while back? Okay. Those problems are always annoying. So this problem was one of those classic ones where, not that classic, but they give you. I closed the Desmos. 2 pi over 3? Oh, I don't know math. Ah. Okay, problem was they gave you a parabola and a point, and you have to find the tangent lines that go through that point. Tangent lines to the parabola that go through that point. There's 2 of them. And then we have to find the angle between those 2 lines, basically. And the options given were all wrong. Oh, yeah, 4 pi over 3 is more than 180. Yeah, that's all wrong. Anyway, I really gotta wrap things up though. I'm exhausted. And my voice is fading, so yeah. YouTube, I'll see you around. I'm just gonna end the stream on YouTube. On Twitch, we'll look for someone to raid. So if you're on YouTube, thanks for being here. And goodbye, YouTube.